I'm audible.
You are audible and visible, clear. Please go ahead.
Thank you. Thank you. So, very good afternoon. I'm very happy and humbled to be part of this wonderful event today. Because as Professor Amitabh was described, I'm a person not too good at sustainability. But nevertheless, I will try to connect my expertise how to sustainability. So when we're talking about using technology, research, innovation, and policy for a sustainable future, I'll go external, so please excuse me if I will out and not say something which is the truth of the today. As of today, you all know that close to 500 gigawatts of energy installation in this country. And out of which actually the peak demand of India is close to 235 gigawatts. The sad part that almost 25% of Indians not able to celebrate a satisfactory Diwali because of peak energy deficit that the country faces today. Now, having double the requirement of energy today, why every Indian in this country do not have electricity? Now, the peak energy deficit before a decade was close to 45%, and today it reduced almost nil. And then because we claim that because of renewable energy integration, today we are going to meet the requirement. But I have a slightly different opinion. The renewable energy is not due to achieving sustainable development goal, SDG of India, but we go for renewable energy because it is mandatory and it is need of the hour. Now just try to understand all the hydro projects are not able to take up. Thermal power plants need to be such. Nuclear is not 100% technology, but we most of the middle class Indians today aspire to have better life, including electric vehicles. Put the country in a point to meet the immediate requirement in the next year. For example, if there is a 5% energy growth, you try to have 5% extra energy from renewable so that you can meet out the requirement of the So that means renewable energy of this country is not to achieve sustainable future, but it is a mandatory requirement to follow. But nevertheless, if we grow significantly, the way we come to be 30%, 40% of renewable. So in the next decade, we will be in a position to contribute significantly. Now, I do have a very strong statement that God is not very kind to genius. Because God has given us energy, especially renewable. Morning, solar, the peak occurs in the evening, wind, the midnight, again the peak occurs in the evening. So most of renewable energy sources that are unique, they are not available to us when we need, and hence the storage technology gains traction, and we become efficiently into storage technology so that it is all the energy that can be stored in capacity. Now, I've been told that millions of electric vehicles are in your road, and the concern is if those electric vehicles are getting connected to the peak hours of this country, then what is going to happen? It's a big question. One side we are talking about sustainability, and another side aspiration, and not to have electric access to many rural Indians. So those electric vehicles which are going to run on the road tomorrow must have electricity. And if they failure to get connected during peak hours can probably the peak energy deficit, which is almost 0.5% a day, will lead to 50%, 4%, 5% over the time. So whatever the additional renewable energy that we use in the system will not be enough to meet the energy requirement of mobility. And hence, I think we need to plan the future in 2 ways. First, energy access to all, and hence electric vehicle charging infrastructure, which must be carried out in a way so that it is not going to cause any challenge to the peak energy requirement of the country. I think this is what actually the whole statement to meet the energy and sustainability that we all have to consider. I could see many young researchers sitting in this room, probably they rethink the growth of the energy sector, meeting out the SDG, that is the Sustainable Development Goals for India, considering the energy deficit of peak energy requirement of the country. Now, coming back to the theme based on which this summit is planned, I am really grateful to the organizing committee members for thinking beyond the reach and bringing such a wonderful get together towards celebrating 60th birthday of the man. I think he is like a guru to me, and perhaps I am very happy to mention in a common forum that the day he got his purposely happened to be in Jaipur and next day to visit the campus. And whenever I interacted with him, I mean, he's a different personality. I think we all have to learn a lot from Professor Prasad. And I'm very sure he will continue contributing in science and technology, not only at Kanpur but also to the nation. So wish him all the very best for his future. And once again, thanks all the organizers for having this event and inviting me for his talk. With this note, due to sort of time, I'm stopping here. Thank you very much.
Thank you very much, sir, for all the details that you have given on energy and sustainability, and at the same time, the wishes for us. Thank you so much. We shift to the next speaker. Again, Dr. Lele, am I audible to you?
Yes, can you hear me?
Yeah, you are audible. So, I just introduce quickly. So, Dr. Lele is the director of HCL, and having served as he has previously served as a vice president and head of advanced materials and alternative energy group at the Reliance Industries Limited. He is a distinguished chemical engineer who earned his bachelor's degree from the University of Bombay in 1988, PhD from University of Delaware in 1993. He began his career as a scientist, and all of us have led his efforts on rheology, complex fluid polymer dynamics, polymer processing during our formative days, and at the same time we also read these days is all the work that we do in the research domain. He played a very key role in the consortium to develop a kind of e-influencer technology and authored numerous papers and patents, and he has multiple awards to his credit, including the Santeshwar Bhatnagar Award. Sir, the stage is yours. Kindly go ahead with your talk.
Thank you very much. I want to present a few slides if that is allowed.
Yeah,
can you share my screen?
Share your screen, yes.
Yes, thank you.
Yes, your slides are visible. You may go to the presentation mode. Yes, it's set, all set. You can go ahead with your talk.
Okay, thank you. So first of all, my congratulations and birthday wishes to Sir Ashutosh Sharma, and also congratulations on his permission. I had the privilege of meeting him recently in Pune, and he offered in person my congratulations to him. He is of course a person with not only great intellect but great wisdom, and I certainly hope that he will continue to guide many of us in his leading position. In the conference, I just want talk about a few personal experiences of what kind of work that I've been doing in what we normally call the value of it. So here are a few slides, and these are all honestly only my personal experiences. So the context is that by 2047 is an important year for India. India wishes to become an Atmanirbhar Bharat with a $30 billion economy. Many challenges facing us. We live in a very unpredictable world. We don't know when the tariffs will come up tomorrow, when they will end tomorrow. Nothing is predictable today. The world is also facing major issues like global warming and disruptions in global supply chains. On the other hand, there are many opportunities. The world is looking for India to provide an alternative to China in terms of manufacturing. We are a country with very high demographic dividend, great opportunity for us there, and an aspirational growing middle class which is reasonably educated. However, our manufacturing sector has only contributes only 14% to the GDP and only 11% of the workforce. And clearly, for India to become really Bharat, the manufacturing sector must grow. And this manufacturing sector must also become more sustainable. And the Honorable Prime Minister has also highlighted the Panchamrit philosophy for how India should become more and more sustainable. So the manufacturing sector also should become more sustainable. And therefore, it is not just about Make in India, but I think first and foremost it should be innovate in India and then Make in India. So we have to look at the innovation journey, and if you look at India, where India stands on the innovation journey, at about low TRS, which involves R&D institutions, number of students registered in those institutions and get educated, and the kind of academic outputs that we have, journal articles and patents, we are doing this quite fine. However, at IIT level, where we suffer, we are not doing that great in the Global Innovation Index, nor the meaningful contribution to R&D, and also not the industry academia interactions. And one of the reasons for where we fail at the higher TRN levels is really what is called the value of debt. So if you look at the TRN table here, and as we move from the TRN 1 to 4 is where primarily the invention happens, and that happens in our academic institutions and research labs, and we are pretty good here. But as we start moving to higher TRS, where we start looking at the prototyping of product or piloting a process, and then of course after that moving into real bringing in investors, making supply chains robust, and actually licensing our technologies. This is the big value of debt where we play miserably big, and that is one of the singular reasons why innovate in India doesn't always translate into Make in India. I come from a laboratory, CSIR and CL, which is in Pune, which was defined 75 years ago. The purpose of this lab was defined as one to advance knowledge and to apply chemical sciences for the good of the people. A very simple statement, but what it actually means is innovation. Because innovation is a journey. Innovation starts from invention and leads to impact. And that journey happens by translating science into technologies that are practiced on the ground. And for the past 75 years, NCL has been a pioneer in walking the journey of innovation. We've had a very large number of technologies which have started from the lab and have reached full commercialization levels. And these are only a few pictures of how in the chemical sector where we work, our science has been translated into real scale products. We publish as a lab about 400 plus papers a year, 60 PhD students, roughly about 70-80 patent filings. We have very clear roadmaps of what we want to do. And despite all of this, our industrial earnings are about 22 crores per year. For a lab that is about 100 scientists, 22 crores is not a very large amount. That accounts to about 20% of our R&D expenditure. We do technology transfer at only TRS 4-5. We do not go beyond that, and that's where the value of debt starts. At least 1 or 2 out of our 10 of our transfer of technologies do reach commercialization, and also so this is also not a very high number. And therefore, the real issue, even for a lab that does so much innovation and so much translation of technology, even for a lab like that, one must realize that the lab to market is a very, very long and difficult road. So there are some personal experiences when we started looking at how to scale up technologies and enter this value of it. The first example is the innovation project that was talked about earlier. We used a very interesting special purpose vehicle called the Unity vehicle, which actually straddles at the quadrant where the market uncertainty is very high and the technology uncertainty is also very high. Which means neither the markets are clear nor the technology is fully mature, and that's the difficult quadrant. And we wanted to actually take a risk and enter technology in that quadrant. About 20 years ago, this country was not even talking about hydrogen technologies. And that's when we started our journey in hydrogen. So you can imagine that the markets were low and the technology was immature. We put up a team of several scientists across 3 different CSIR labs, and we brought industry partners on board even at early stages of technology development. We took the whole technology through 3 stages, starting from academic innovation to a full product launch. Along this journey, we produced about 13 PhDs, more than 100 papers, and several patents. And ultimately, what we wanted to do and successfully did was this kind of fuel cell stack, which is a very complex technology. This technology resulted ultimately into India's first fuel cell car, India's first fuel cell bus, and India's first fuel cell hydrogen powered buses and catamarans on the road yet. So technology advancement has happened, prototype developments have happened, we have crossed those valleys of death, and we are now entering into what is called the market readiness levels, and that is where issues can come up. There's nothing to do with technology, it's to do beyond technology. And why am I talking about this is because when we get audited for programs like this, the audit asks us why are your technologies not commercialized? And it's so ridiculous a question because they don't even understand the difference between transfer of technologies and commercialization. This is one of the issues that labs like us and academia who want to cross this valley of death will always face in India. The second experiment that I'm telling you about is the Pune Hydrogen Valley. Again, a very interesting experiment. We are going to develop all hydrogen technologies in one place: hydrogen production, hydrogen storage, and hydrogen utilization. We are looking at a very novel technology for producing hydrogen through catalytic transformation of bioethanol. This is about 2 tons per day of hydrogen, so it's not way more than a lab scale, 2,000 kilograms per day. The hydrogen will be stored in a variety of different containers and will be transported. And the user, for the first time in this country, we are looking at fine and specialty chemicals. This is an industry sector where NCL is very deeply connected with, and they use a lot of hydrogen. And so we have end-to-end from hydrogen production to hydrogen utilization, the entire supply chain mapped up. We are also looking at developing 2 buses, one based on fuel cell and one based on internal combustion. So very interesting initiative by both the National Green Hydrogen Mission and the DST. Our project is about 125 crores, where nearly 2/3 is coming from industry, 1/3 is coming as a viability gap fund from the NGHM. The Pune Hydrogen Valley offers really an innovation platform to bring innovators on board. So there's a company that has developed the bioethanol technology. There are companies who are looking at substituting grey hydrogen with green hydrogen, and there are companies, startups included, which are looking at mobility. So we're bringing all these innovators on board on this very interesting platform, and more importantly, we are looking at scaling up through this valley of death from TRL2 to TRL8. Where are the problems in this? This is all exciting. We submitted the expression of interest in July 2023. The award letter was received July 2025. It has taken 2 years for this exciting program to get even kick started. And the reality today is that investors and industry have no patience of 2 years to wait this long. They cannot deal with uncertainty. So this is again, while technology is not a problem here, we are very keen and well ahead in developing these technologies and scaling them up. There are issues other than technology which prevent us from crossing this valley ahead. The third experience that we are doing right now, again, an exciting program. We are looking at a molecule that called dimethyl ether. is basically converted from methanol that will come from India's coal and biogas gasification. DME is an interesting molecule because it is a direct LPG substitute. Certified as a fuel, CSIR has invested so far about 10 crores in developing this technology. The global market potential is tremendous. We have a globally competitive catalytic technology protected by 6 patents, both Indian and world. We've already finished the 20 liters per day lab pilot plant, and we're just about starting our first experiments in a 250 kilograms per day industrial scale pilot plant with our industry partner. All the due diligence has been completed and expression of interest is from a large number of companies. So we have a clear roadmap of how we want to move from lab to the market. Where are the challenges here? The entire pipeline from idea to final end use has so many players in there. NCL comes with technology, there is a process engineering company that actually does the detailed engineering. There are regulators who certify DLE as a fuel. There are manufacturers of DLE, there are retailers of DLE, and finally the end users of DLE. In order to go from lab to market, all of these stakeholders have to come on board. And the institute of the R&D lab, which is passionate about developing these kinds of technologies, has actually to work with all of these partners together, bring them on board and take this program forward. There is a lot of program management, personnel management that is even more challenging than technology development. Very interesting learning here. The last experience is a very interesting program we are doing, Patch to Continuous. We are talking to Indian chemical industry. It is a very aspiring sector. We are considered as a global manufacturing hub today. This industry contributes to 7% of India's GDP. It is valued at $200 billion today, but also emits about 57 million tons of CO2, so not a clean energy. We are the pharmacy in the world today. 24% of North America's medicines come from Hyderabad. The specialty chemicals industry today is exporting $2 billion worth of goods, and by 2040 is going to go 10x. There are about 17,000 companies in India who are in this business. They do conventional manufacturing, which are batch processes, which gives them a lot of flexibility, allows them to do multi-phase reactions. But typically conversions are low, selectivities are low, and therefore downstream purification costs and therefore utility costs are very high. The processes are also not very safe, long batch times, very large footprint, and back-to-back consistency. These are all issues with today's conventional manufacturing. What are we doing? We are suggesting them, and we are developing for them a complete paradigm shift technology, continuous manufacturing, also called flow chemistry, but it's not about just the chemistry, but all the downstream part as well. These are plants with very small footprints because they are continuous, the quality is very consistent, conversion selectivity are very high, very short response time, very safe to operate, therefore very low utility cost, and can be very easily utilized. This is a paradigm shift for an entire sector. We have a large number of companies who are our partners. We also have a catalytic lab in the UK as our partners, and this is a very interesting model that we are looking at how to scale up these technologies for a large number of partners, not for one company, but we're talking of hundreds and thousands of companies here. So very exciting program here, and we are now completed already phase 1. In phase 2, we are now planning bigger 100 kg per day kind of modular pilot plants. So what are the learnings from all of this? This is my last slide. I believe Indian R&D and academic institutions really are not set up to cross this valley of death. Okay? The likes of institutes like the Prof or the catapult institutions are completely missing in this country. I certainly believe that we need to innovate an India-specific model of institutions that will enable us to cross this valley of death, and therefore innovate in India can become also make in India. There are challenges, more difficult than technology development itself, and I really believe that techno-entrepreneurs should not be allowed to spend more time in anything else but scaling up of technologies, because that is their forte. The government funding policies and workflows based on our PFRs and PFMS are honestly not very conducive to not just R&D but development and deployment, the demonstration and deployment as well, which is the value of death. And therefore our policies have to be crafted by understanding what are the pain points where you want to navigate these values of death. I think there is silver linings on the cloud. The recent RTI schemes and the recent ANRF schemes could be interesting. We will have to try them out. But the world is not waiting. Look at China, $500 billion R&D investment compared to $15 billion R&D investment of this India. 2.6% of GDP versus 0.65% of GDP. 20% of our GRD comes from industry, 75% of China's GRD comes from industry. They are already leaders in AI, semiconductors, clean energy, mobility, pharma, biotech, critical minerals, but we have the world is not waiting and we need to move very fast. And therefore, process reforms and accountability today in R&D are the absolute need of the hour. Look at the other side, Indian shareholders and the industry have very poor scalability right now. It's very difficult to get access to patient capital, and patient capital is critical to take technologies from lab to market. The industry expects process guarantees even at TRS 5 technology transfer, which is laughable. The IP licensing rights are expected for CSIR projects, which is absolutely not necessary, and it's not even allowed. And today, government auditors, as I said, ask us why technology has not been commercialized. You cannot ask this question to an R&D lab. There are many things other than technology that leads to commercialization. But the silver lining here is that we find that mid-cap companies have very high aspirations. There are many land foundations which are emerging, and few HNIs they seem to be very passionate about funding R&D in India. And I think this is where India will go ahead in terms of bridging this value there. So thank you very much. These were my thoughts, and I thought for the topic of this conference, I thought I would like to share some of my personal experience. Thank you.
Thank you so much for joining and sharing your views on this